I chose to focus on the study of perfect numbers for my final project. So a perfect number is a number whose factors outside of itself add up to itself. So for 6, 1 plus 2 plus 3 equals 6. And so 6 is a perfect number. The study of perfect numbers has unknown beginnings. It's believed that the Egyptians came across them, and Pythagoras and his followers also studied them. However, the first concrete mathematical proof involving perfect numbers comes from Euclid, where he figured out a way to compute or to generate perfect numbers by using prime numbers. And since his derivation of that formula, mathematicians have been focused on answering 3 questions. What are the perfect numbers? Is the set of perfect numbers infinite? And are there any odd perfect numbers? So Euclid's, it seems the first 4 numbers were known, and Euclid's discoveries were basically that if you generate numbers by doubling the current number to get the next term, so 1 times 2 is 2, 2 times 2 is 4, so on and so forth, that adding up the terms you generate until they equal a prime, and then multiplying that prime by the last number generated will generate a perfect number. Example would be 1 plus 2 plus 4. Those 3 terms are added together equals 7. 7 times 4 equals 28, which is a perfect number. We can generally notate this as that formula equals 2 to the k minus 1. So 2k, so 2 to the 1 minus 1 equals 2 to the 0, which equals 1. And then 2 to the second minus 1 equals 2, so on and so forth. And then Euclid also found that the prime number that's generated by adding those terms together can simply be written as 2k minus 1. So we generate 3 terms to get 7. So then 2 to the third is 8. 8 minus 1 is 7. And so therefore the formula for a perfect number is 2 to the k minus 1 times a prime that can be written as 2 to the k minus 1, or sorry, 2k minus 1. His formula has been used to find more perfect numbers. However, questions remain on whether his formula can generate all perfect numbers, or whether there's another formula that can do that. And then mathematicians like Hudrol Regius, I'm sorry, I butchered that, found k values that do not yield a perfect number. Currently, mathematicians have found 51, and there are still questions on the property of those numbers, along with whether they can be generated other ways. The second question is, are perfect numbers infinite? Nicomachus first theorized they were with no proof, and currently the question remains unsolved. Because you can use prime numbers to find perfect numbers, the question of whether or not perfect numbers are infinite is tied to whether primes are infinite. Because if primes are infinite, you will always be able to find a prime that can be written as 2 to the p minus 1, and then you will always be able to create new perfect numbers. So those 2 things are intertwined. The final question is, do odd perfect numbers exist? This has been neither proven or disproven. However, mathematicians have proved that odd perfect numbers must have certain qualities. So Nicomachus claimed that all perfect numbers were even, again without proof, and ended in 6 and 8 alternatively. Cataldi proved this false by finding perfect numbers that ended in 6 back-to-back. However, Euler found that perfect numbers do end in either 6 or 8, just not alternatively. Sylvester worked on finding the minimum amount of prime factors an odd perfect number must have. So he found it must have 8 distinct prime factors. And then currently research like that has led us to know that an odd perfect number must have more than 300 digits and a prime divisor greater than 10 to the 6th. Mathematicians have also found spoof numbers that have the necessary qualities of an OPN, but lack the qualities of a perfect number. Descartes found one that has these qualities, but the prime number he used to generate the odd perfect number was not actually prime. Currently, Dr. Pat Nielsen and his team at BYU are using spoof numbers to determine more properties for what an actual OPN has. and they are hoping to either find a quality that a spoof number has that an OPN cannot have, like a spoof number must be divided by 105 and a perfect number cannot be divided by 105, or by further increasing the criteria that a non-perfect number has and cutting out the numbers that it can't be with those criteria. Because spoofs and OPNs are in a similar family, an OPN must have all the qualities of a spoof plus more specialized ones, meaning if a spoof has a quality that a perfect number cannot have, then odd perfect numbers do not exist. So that is where the current attempts at finding an odd perfect number stand. And yeah, that is what I have learned about perfect numbers so far.